Okay, so for number 13 on the review, um, let's see, we have this angle right here is 3x minus 19, be 6x minus 41, and then of course out here this exterior angle is 5x plus 12. All right, follow the three-letter path, B to C to D, and it's that one. So this is the exterior angles theorem. Let's not be fooled by thinking that this is an interior angle. Okay, in that case you just add them up to 180. So that's going to be the common mistake. But the exterior angles theorem is that the two interior angles have a sum equal to the measure of the exterior angle, the other one's exterior angle. Okay, so that's the exterior angles theorem, and we've got to use that to solve this problem. So what I want to do is I want to add the two interior angles, and that should equal the exterior angle. All right, so now it's just some algebra. 9x minus 60 equals 5x plus 12. Okay, make sure we're careful on from here on out. Avoid any minor mistakes. Okay, so we're keeping it balanced. 5 by 4 and x equals 18. All right, so don't stop there though. It does ask for the measure of every angle. All right, so now's the stage where we're going to plug back in. All right, so we've got the 3x minus 19. We're going to sub in 18 for x. Let's see, 54 minus 19. What do we got? 35. So that's going to go at angle A. 6x minus 41. Plug in 18. What's that? 108 minus 41. Looking at 67. And then the 5x plus 12. 90 plus 12 is 102. And that should work because those two should add up to that. One more angle just in case we needed to. These two are a linear pair. So I'll subtract from 180. And what we have is, just redraw this. I'll have 35 here at angle A. Angle B, we're going to have 67. The interior angle, we're going to have 78, and the exterior is 102. Okay, so that takes care of that one. Okay, so make an argument that explains why the measure of an exterior angle equals the sum of the remote interior angles. So that's basically exactly what we were just talking about. Making an argument, that's not a full-on proof. So what I'm going to do is just create a diagram to reference. Okay, so the exterior angle is that angle right there. What I'll start with, actually, you know what? I'll number them. It makes it a lot easier. 1, 2, 3, and 4 instead. Okay, so what I'm going to do is my first argument is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. Okay, and that's simply angles of a triangle, interior angles, I should say. Interior angles of a triangle have measures that add to 180. Okay, so that's my first argument. Now, the measure of angle 3 plus the measure of angle 4 is also 180. And that's because they form a linear pair. And linear pairs are supplementary, and then they add up to 180. So we'll talk through that angle 3 and 4, add to 180 because they form a linear pair. So that's supplementary, which means add up to 180. All right, now it's some algebra. Really simply, um, if we take both of these equations, right, and we subtract the measure of angle 3 from both sides, what's going to happen is you're going to get two different quantities that add up to the same thing. Now that's a little tricky, but I'll show you what I mean. I'm going to take this first equation, I'm going to rewrite it. I'm going to subtract the measure of angle 3 from both sides. So we're rewriting the beginning, and now if I subtract away the measure of angle 3 from both sides, it turns into that. Seems a little weird at first. I'm going to do the same thing over here. Take away the measure of angle 3, and look what ends up happening. We've got two quantities that are identical to the same expression. Okay? So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4, because they are both equal to 180 minus the measure of angle 3. A little strange, but that's how this proof works. I know you don't have to do a full-on proof. I'm probably going overboard, but I want to make sure that we get this done. Okay, so that is basically those are the two remote interior angles. Having measures that add to the exterior angle measure. Okay, so that's that one. All right, so we're given that it's isosceles with AB the same as BC. BD bisects that angle ABC, right, follow path, and I got to prove these two are the same. So I'm going to probably go with the triangles congruent by side angle side, it looks like. All right, so I'll need a little bit more room, and that's my plan. So if I'm going to do this by side angle side, let's get a pair of sides first. We're going to say 1. AB is congruent to BC. Well, it says equals, but congruent, same difference. And now we'll go after a pair, so that takes care of the sides. I'm going to go after a pair of angles. First, I need some help on that, though. BD bisects angle ABC, again, because it's given. All right. The result of that, or the conclusion from number 2, is that angle ABD is congruent to angle CBD, and that's by definition of angle bisector. You can always explain that if you forget the math rule and what to say there. You know, basically an angle bisector creates two equal angles. All right, that gives us our pair of angles. Now we got to go after the last pair of sides. BD congruent to itself by reflexive property. And finally we get the triangles the same. Triangle ABD congruent to triangle CBD by the side angle side triangle congruence theorem. All right. And then 6, angle, what was it again? Angle A, I think. Angle A is congruent to angle C, and that's because of the congruent statement. I'm going to say corresponding parts of congruent triangles are congruent. Right? They're the corresponding parts. Corresponding angles are A and C of those congruent triangles up in 5. All right, very good. I'll make the, let's see, that'll be it for this video, and pick up on the next one.